Let's talk about the delete operation. So here we have a try with two words, car and care. And for simplicity, I haven't shown the root node that is empty. Now let's say we want to remove the word car. We start from the root, and using recursion, we do a post-order traversal in this tree. So we go all the way down until we find the last node for the last letter of this word. That is the R. Now, in this case, we cannot physically remove the R because otherwise we'd end up removing the word care as well. So we simply remove the end of the word marker from this node, and we're done with the deletion. Now let's look at another example. What if you want to remove the word care? Once again, we start from the root, and using recursion, we do a post-order traversal until we get to the last node for the last letter of this word. That is the E here. Just like before, we remove the end of the word marker, and then look at the children of this node. In this case, this node doesn't have any children, so we can physically remove it from our tree to save space. So on the way back, when we're done with all the recursive calls, we get back to the R, and this is where we remove this node. So when we're back in the R, we ask the E if it has any children. Since it doesn't, we can physically remove the E from the R. Now, in this case, our deletion stops here because we still want to keep the word car in our try. But let's say we didn't have the word car in our try. So we have to continue removing these nodes for every letter of this word, or we get back to a node that is the end of another word. So if that's the case, we'll stop the deletion right there. Now, with all that, I want you to spend 20 minutes on this exercise and implement the delete operation. It's a little bit tricky, but with all the information you have, I'm pretty sure you can solve this problem on your own.